Hello everyone. In this video lecture, we'll be learning about mode theory. So in order to explain the propagation of light through an optical fiber, we'll be using mode theory and ray theory. Ray theory we have already discussed, that is laws of reflection, refraction, ray optics, Snell's law. These all comes under ray theory. So in order to explain the mode theory, the assumptions that we use are: 1. The light has dual nature, that is, it has particle nature as well as wave nature. And then the light is considered to be a form of electromagnetic radiation that has electric and magnetic fields with it, and these fields are oscillating. So the mode theory also suggests the light wave can be represented as a plane wave. So with the mode theory, we can see how different modes of light get propagated along the fiber with respect to these electric fields and magnetic fields. Depending upon the presence and absence of electric fields and magnetic fields, or the combination of these two, we have different modes that are transverse mode, transverse magnetic modes, transverse electromagnetic modes. So with this mode theory, we'll get to know how each of these modes propagate through an optical fiber in the presence of electric fields and magnetic fields associated with the light. So in order to explain further the mode theory, we have considered three different modes here: TE0, TE1 and TE2 inside a cylindrical optical fiber. So here we have a cylindrical optical fiber with core N1 and cladding N2. That is a refractive index with core with a refractive index N1 and cladding with a refractive index N2. So the three different modes we have considered transverse electric modes here, that is TE0, TE1 and TE2. Okay, so other important criteria related to mode is the order of the mode. So in TE0, the order of the mode is 0. In TE1, the order of the mode is 1. And in TE2, the order of the mode is 2. So what is the order of the mode? The order of the mode is nothing but the zero crossing of the field across the reference line. Here the reference line is denoted by a dashed line. So in TE0, we can see there is zero reference line. Similarly, in TE1, we can see one crossing across the reference line of the field. In TE2, there is two field crossing across the reference line. So as you can see from the figure, we have three different modes here: TE0, TE1 and TE2, and order of these modes are 0, 1 and 2 respectively. For TE0, the order of the mode is 0. That means we have 0 crossing of the field pattern across the reference line. The reference line is a dashed line, as you can see from the figure. For TE1, the order of the mode is 1, and so that means there is 1 crossing of the field pattern across the reference line, that you can see in the figure highlighted in a blue square box. And for TE2, the order of the mode is 2. That means there is 2 crossing of the field pattern across the reference line. Okay. Another thing that we can see from here is that for lower order modes, low order means 0, 0, 1, that is low order modes. For low order modes, we can see the concentration of the field pattern is more towards the core. So as the number of modes increases, as for higher order modes, this concentration will be more towards the cladding. Okay, another type of mode is called a leaky modes. For these type of modes, you can see the concentration, the field pattern is more towards concentrated towards the core and lesser towards the cladding. For leaky modes, the concentration, the field pattern concentration will be more towards cladding. For in that type of leaky modes, there will be a radiation of power towards the cladding, and to prevent this, we will be using coatings which absorb coating outside the cladding, which will be absorbing such type of power radiations that are coming out of the cladding. So that is all about the modes. Now in the next slide we'll see the condition for propagation. So you can see the condition for propagation, that is N2k less than beta less than N1k, where beta is the propagation factor and k is equal to 2 pi by lambda.